In this unit, we're going to go back to graphing, and we're going to talk about graphing a new type of function called a quadratic function. So far we've worked with mostly just lines, graphing lines, y equals mx plus b, slope, rise over run, etc. So in this unit, we're going to talk about a new type of graph, and we're going to define it, talk about its shape, and some of its properties. Okay, so let's start off with what is a quadratic function. Now, we've seen this word used before to name something that has an x squared. So that's kind of what a quadratic function is. So it's a function that can be represented by the form f of x, or, we've also used y equals, we've used f of x equals ax squared plus bx plus c. So similarly, like a line was y equals mx plus b, this equation, ax squared plus bx plus c, is how we represent a quadratic function. And so notice it's quadratic because the highest degree is 2, and we talked about that in the previous unit. So we're kind of connecting the units together a little bit here. So we're going to move from the algebra piece of it to now the graphing piece of it. So in this equation, or in this function, a, b, and c are values, meaning they're numbers. So a would be a number, b would be a number, c would be a number, and a can't ever be 0. So those are the kind of the rules of what the line could look like. So for example, we could have the equation be something like f of x equals 2x squared plus 3x plus 1. All a, b, and c are numbers. A isn't 0. And then we're going to talk about later what each of these numbers mean and how they go together. But for now, just know that if you see something with x squared as the highest degree, we can call that quadratic. Okay? So what does a quadratic function look like? Well, a quadratic function looks like this curve here. So let's move up a little bit. I'm going to zoom in. So this guy right here, this curve, just follow my pencil, that's a quadratic function. We also call this a parabola. This shape of something is called a parabola. It's a really common shape in the real world. When you throw a ball in the air, it forms a parabola. Actually, anything being put in the air and then falling back down to earth is going to form this parabola shape. So it's a very, very, very common shape, and it's used a lot in math and in the real world. So let's define some parts of a parabola that are very important. So the first thing that's true of a parabola is finding its vertex. So this guy right here, the very peak of the curve, is a vertex. Okay, it's where the graph goes from up to down, and then it can also be where it goes from down to up. So if we go down to this bottom shape down here, see, this is also a parabola because it just curves downward. This guy right here is this one's vertex. So it's where it goes from going down to going up, the very bottom or the very top of the parabola. So that's the first word we need to know. The second thing that's really important to know is its axis of symmetry. So do we see this little invisible line that's going through the parabola, cuts it right in half, basically. This line is called the axis of symmetry. So it's the axis of symmetry, and in the bottom graph, it's this line right here. And it's invisible. I'm drawing it in here to show you, but typically the axis of symmetry is not ever drawn in. We just know it exists. So it's a vertical line cutting through the shape. That's the axis of symmetry. Okay. The other words that we're going to use are familiar ones you guys have seen before. This one right here, that guy, that's your y-intercept. Notice that that's where the curve, follow my pencil, touches. This is the y-axis, this is your x-axis right here. So that's where the curve touches the y-axis. So this is the y-intercept, and we should be very familiar with that word. We used it a lot in lines, where the line touches the y-axis. So in this curve, it's right there at +2. And in this bottom graph, it's right here at 3. So y-intercept, where the curve touches the y-axis. Okay. And the last word is where the graph touches the x-axis. So in a parabola, this happens in two places, typically. Sometimes it happens in one, sometimes it happens in none. We'll talk about that. But the x-intercept is really important in parabolas, more than in lines. Okay, the x-intercepts have a lot of different meanings. So we call these the x-intercept, and there's one right here, and there's another one over here. So there's two in this graph. We're going to use a lot of different words for x-intercept, so we're also going to call these zeros. They're also called solutions. So anytime going forward in this unit or in further units, I use the word solutions, zeros, or x-intercepts, that all those things mean the same thing, okay? So same thing down here. These guys are also x-intercepts, zeros, and solutions. So just know that I'll use those words interchangeably, and that's okay. So there's your basic anatomy of a parabola. All the words that I'm going to be using, and I'm going to expect you to use these words as well. Okay? So let's take a look at practicing looking at some of these words on a parabola or a quadratic. So here's a parabola going down. What is the name for this? Is this the vertex, axis symmetry, y-intercept, or zero? Well, that's an x-intercept, and we also call that a zero. So that's a zero of that parabola. The second one on the right, which of the following is a zero? So now I'm going to look at my graph, and remember zeros, those x-intercepts, there's one right here, and there's one right here. And then I need to write down those coordinate pairs for those 2 points. So this coordinate pair right here is 1, 0, and this coordinate pair is -3, 0. Well, are any of those listed here? Yep, C is listed there. So we should be able to identify x-intercepts and write the coordinate pair for those. Okay, remember zeros and x-intercepts are interchangeable words. The third one, what's the name for this? So this is my parabola right here going down. This straight line cutting right through the middle, that's my axis of symmetry. Okay, that's my axis of symmetry. And we can even write the equation for that axis of symmetry. It's at x equals 2. And we'll have practice doing that too, because remember, a vertical line has an equation of x equals a number. The fourth one, this is a parabola facing down. What's the coordinate for the vertex? Okay, the vertex is that point at the very, very top or very, very bottom. So that's my vertex there, and that coordinate is -2, 4, and that's right here at C. The fifth one, down here, let me move my book a little bit to the right. Okay, so 4, -2 is an example of a, so let's find 4, -2, so that's right here. And what is that point called? Well, that's the very bottom of my curve, so that's called a vertex. And finally, the last one, this graph does not have a vertex, axis of symmetry, y-intercept, or 0. Well, it has a vertex right here. Okay, so can't be vertex. It has an axis of symmetry, that's this guy right here, so can't be this. It has a y-intercept way down here. But does it have any zeros? Does this curve ever touch the x-axis? No, it doesn't. So this graph has no zeros, and that's totally a possibility. Some parabolas just don't have zeros. They will never cross the x-axis, and that's okay. Okay, so, and we're going to talk about that more too. Okay, but just know that a parabola does not have to have zeros, x-intercepts, or solutions. Okay, so that's kind of a basic vocab for this unit. Looking at a parabola and defining its different parts. The second thing we want to be able to do in this learning target is graph these functions. We want to be able to graph them just like if I gave you a line, y equals mx plus b, can you graph them? So that's the goal for this learning target. So the most basic quadratic function is called the parent function, y equals x squared. You need to memorize this. This guy is called the parent. He's the boss. He's your very basic quadratic function. Memorize what it looks like. I'm going to show you right now. Okay, so in every graph, we have to pretty much get a table of values in order to find plot points. So we haven't done this in a long time, and that's okay. We're going to kind of go over it now. So if I make a table, here's my table, x comma y. Now, in my tables, and this is something to learn going forward, we want to have some negative x's, we want to have 0 for x, and we want to have some 1s for x's. So don't start your table off with 1, 2, 3, 4, 5, because then you're not giving yourself any negative values. I want to have some points along the bottom here. So when I start a basic table, I'm going to pick these basic x values. It gives me a little bit taste of the negative, and it gives me a little bit taste of the positive. Okay, now here comes the annoying part, right? So now that I've got some x values, in order to find my y's, I have to plug in x to my algebraic equation. So my algebraic equation is y equals x squared. So y equals x squared. So that's my equation. So if I want to find what y is at x equals negative 2, I'm going to plug in negative 2 and get 4. So what that means is when x is negative 2, y is 4, and I can plot that point, negative 2, 4, onto my graph. That's how an equation is related to a graph. It's been a while since we've done this, but this is how we make tables of values. If we do negative 1, y equals negative 1 squared, that gives me positive 1. So I've got a point at negative 1, 1. If I do 0, oops, y equals 0 squared. Well, 0 squared is just 0, so I have a point at 0. Let's do the last two. If I do 1 squared, positive 1 squared, I get 1. So there's a point at 1 comma 1. And if I do 2, I get positive 4. So quadratics are kind of, oops, that's the wrong point. Quadratics are kind of interesting in that they have this mirror effect, which other graphs don't have. Meaning, when I look at my vertex here, I'm going to have points that are mirrored around the axis of symmetry. So if I have a point here on 1, I'm going to have another point on this other side. If I have a point here at negative 2, I'm going to have a point on its other side. So if I have a point at negative 3, I'm going to have a point on its other side. So if I were to continue this table and do negative 3 squared, I'd get 9. And if I do positive 3 squared, I also get 9. So at both negative 3, I get 9, and at positive 3, I get 9. So this is the pattern of a quadratic function. You need to memorize these points and memorize the parent function going forward. And it's not too hard to memorize. Notice they're all perfect squares. 1, 4, 9. 1 squared is 1, 2 squared is 4, 3 squared is 9. That makes sense, right? Because we're looking at the function x squared. So you're looking at that relationship of numbers that are being squared, so you're going to end up having a lot of perfect squares in the parent function. Okay? Now, I'm not going to make you do this every time for all these graphs. I have a much easier way, but I need you to be able to come up with a table for this and know these key points. I need you to memorize this parent function for sure. Okay? So let's take a little bit look at some other vocab we need to talk about with this parent function. So concave up and concave down. Concave means, is it facing upwards or is it facing downwards? This graph is going up, so this is a concave up graph. Okay. Is my vertex at a minimum or a maximum? So this is just looking at the vertex, and when you think minimum, you want to think smallest part, and when you think maximum, you want to think biggest part. So when I look at this graph and I look at the vertex, that vertex at the very smallest point of my parabola, so that's actually a minimum. Where is my vertex located? 0, 0. That's right there at 0, 0. The axis of symmetry is the invisible line. I'll draw a dash through here. That guy, you can't really see it very well, but I'm drawing an invisible line through here. That axis of symmetry exists at x equals 0. There's a connection between the axis of symmetry and your x value of your y-intercept. They'll always be the same. So that kind of helps you do the axis of symmetry a bit. My y-intercept is at 0, 0 because it touches the y right here. I have 1, 0 because that's where it touches the x-axis, and that's also at 0, 0. And then we're going to come back to this domain and range. And it's been a while since we've done domain and range, but I'm going to remind you that domain, remember, is all your x values left to right. So you can write x and y above here to remind yourself. So my domain is going to be negative infinity to infinity because it's going forever left and going forever right. My range is bottom to top. My very bottom value is 0 right here. And the top has arrows, so that means my top is infinity. It's been a while since we've done domain and range, so this might be something you're gonna have to practice to kind of trigger your memory a bit from I think the last time we did it was unit 7. Okay. So that's your parent function, and these are some of the vocab that I need us to be able to do and describe. Let me now show you a much easier way to graph these than doing a table by hand, because this is going to take a really long time to do. So you're going to need your graphing calculator for this piece. I have a few to borrow, but I've been telling you guys all year that you're going to need this calculator. So the graphing calculator is going to come in very handy here. In fact, if you don't have one, you're going to have to do it by hand. And I don't want you guys to have to do that, but without a calculator, it's going to be tricky. So here I've got a new quadratic function. Now I've added this number in front, a 2. I've put a coefficient. All this does is transform from the parent. So it's going to look like the parent function. It's still going to be a curve, but this 2 is going to kind of affect how either tall or skinny or whether it goes up or down. It's going to change how it looks. Okay, so I'm going to take my calculator. Okay, and this is important, so pay really close attention here. You're gonna see your blank screen here, and you're gonna hit the y equals button right there. So y equals, and you're gonna get this list of equations here. And all you're gonna do is you're gonna type in your function. So my function is 2x squared, so I'm gonna type in 2, and then I'm gonna hit the variable button, which is right here. It looks like xt, and then it's got a theta and an n, and when you press that, it's gonna pop in an x. Then you need to do a squared, and to get a squared, you can hit the little tent button here. That's going to pop up an exponent, and then you just hit the number 2. Okay? So that's, I type in the equation just like it looks. Okay? Now, I can hit enter, but it won't do anything. So hitting enter doesn't do anything. That's not how we get the graph. To get the graph, you're going to hit the second button right here, the blue button, or I think it's yellow on some calculators. So you're going to hit second, and you're going to hit table. And it's going to populate a table for you. Okay? And notice that here are my x values in the left column, and here are my y values. Okay, so on this problem, I'm giving you x values starting at -2, so I'm going to scroll down to -2, and what's its matching y value? 8. So I know that at -2, my y value is 8, so I can write that in there. Scroll down again, at -1, my y value is 2. At 0, it's 0. At 1, it's 2. And at 2, it's 8. So this is really helpful to have a calculator that can make a table for you. I still expect you to be able to make a table on your own, but this is going to save you a lot of really precious time. If you want the calculator to show you a picture of the graph before you plot points, you can hit this graph button right here, and it's going to display a graph of the parabola for you. You've done it right. If it looks like the correct shape, it looks like a parabola, and now you have a nice picture to go off of. So the calculator is pretty critical here in this learning target. So I'm going to go ahead now and graph this onto my grid. So -2, 8, -1, 2, 0, 0, 1, 2, and 2, 8. Make sure you connect it and you draw arrows at the top. And that's how we graph a parabola. Okay? Parabola needs at least 5 points. If you graph with less than 5 points, it's not good enough. You have to have at least 5 to graph a parabola. Okay? Let's try one now that has a fraction in front. Fractions really don't change the process at all, except what you're putting into your calculator. So to get back to your input, hit y equals again. Clear out the first equation, because you can only have one equation in there to show up on the graph. Put your 1/2 in parentheses, like always. Hit your x, and then hit your squared. Second graph, and there it will populate your table. Now I have to scroll up to -4, and then it's going to give me my list of values. So I've got -4, 8. I've got -2, 2. -1 is at 0.5. 0, 0. 1.5, 2, 2, and 4, 8. Okay, so there's my points. So I can go ahead and plot them. -4, 8. -2, 2. -1, 1/2. And then I'm just going to mirror these. Okay. Now, oops, I'm sorry. That one should be over 1. And there's my parabola. A couple things to note before we go on to the last example, I know this video is getting kind of long, is that when I've got the numbers in front, remember this is like here's my basic equation, right? AX plus BX plus C. So A is this guy right here in front of my X. That's this number and this number. So we're now looking at something that A does. And this is the same as it was in Unit 7. This guy is a stretch because notice it's a lot skinnier. See how this one's skinnier and this guy is a little wider? So if it's above 1, if A is above 1, just like in our absolute value unit, it's a stretch. If A is a fraction between 0 and 1, that is a shrink. And that doesn't change, that stays the same for quadratics and absolute value functions, okay? And notice that both of these go up. And they both go up because A is positive. Okay, so that's important to note too. So they are concave up when A is positive. Okay, and so my last example is now going to show you what it's like when A is negative. Okay, so this is my last example here. Okay, and this is the negative parent function. Okay, so if A is negative, I've got a negative x squared. So I'm going to go ahead and put this in my calculator to save a little bit of time. So there's my table. And now when I put this into my calculator, let's clear out the old one. So clear this out, and I'm going to just put negative now, x squared. And when I hit graph and get the picture, all of a sudden now, what's my parabola doing? It's going down. So when A is negative, my graph is going to go down. I can get my table. There are my table of values. So at -2, I'm at -4. At -1, I'm at -1, 0, 0, 1, -1, 2, -4. So there I've got my table of values. I can go ahead and plot those onto my grid. So I've got -2, -4, -1, 1, 0, 0, and 2, -4. I'd also have -3, 9 and +3, 9 if I were to continue that table going. Okay, so when A is negative, this guy goes down. See how he's pointing down? And my vertex now is at the top of my graph, so that now is a maximum. My vertex is at 0, 0. It's right here. My axis of symmetry is still at the same place. It's still that invisible line going through 0, so it's at x equals 0. The y-intercept is at 0, 0, and the x-intercept is at 0, 0. They're both right here in the middle. And then my domain, it's still going left forever, right forever. So that domain doesn't change. Negative infinity, infinity, but now my range is going to be different. The very bottom of my range is now arrows. So that means the bottom is negative infinity and the top is 0. Okay. So let's take a look at these two other examples down here. Go ahead and try and do this quickly. I know this is kind of taking a while here. So if I put this into my calculator, go back to y equals, clear it out, and do -2x², and then go to my table. I'll populate my table of values, -2, -8, -1, -2, 0, and then -2, -8. Okay. So I'm going to plot these. So the pattern I want you guys to really see here is the connection between your A and what your graph looks like. That's the real connection here. Okay, so notice this guy is going to go down and he's going to be a stretch. So before I even graph this guy, I know he's going to go down because he's negative. And I know it's going to be a shrink because that's a fraction between 0 and 1. So I know that even before I put it into my calculator. So when I do put it into my calculator, I'm going to put negative 1 divided by 2, put that in parentheses, make sure that that's in parentheses, and then x squared. When I graph, I can predict what it'll look like. It's going to be wider, and it's going to go down. Okay, so that's really the heart of this learning target. I'm going to go ahead and finish up this graph. I appreciate your patience in listening to this video. I know this one took a while, but it's a pretty brand new concept, I think. I know you're going to have a lot of questions, and that's totally okay. Take your time on this one because it's pretty critical for the rest of the unit. So I'm going to go ahead and finish this one. -4, -8, -2, -2. There we go. And then I can just mirror the rest. Okay. So takeaways, all this vocab is critical. This vocab up here is critical. Takeaways, knowing what A does to your graph, and I've kind of listed it at the bottom here. So at the very bottom, the leading coefficient A determines whether it's up or down. It also determines stretch or shrink. So when you're going to start your practice, those are the kinds of things the question I'm going to be asking you. I'm going to ask you to describe the graphs, graph the graphs, and determine what A is doing to those graphs. Okay? Good luck.